Hello everybody, welcome back to our channel. In this episode we're going to be solving a Physics 7C practice problem on the topic of standing waves. As usual, if you're finding this content helpful, please make sure to leave a like and subscribe. It really helps promote our channel. So this is the question that we are going to be solving. This is a final exam question on standing waves and then a little bit of a secondary part on bits. So Aurelia and Argenta are the organist and lead guitarist respectively of the band Precious Metal. Before each concert, they need to tune one of Argenta's 1 meter long guitar strings such that the fundamental is in tune with the fundamental of the 0.75 meter long reed pipe of Aurelia's organ. However, since the speed of sound in air is dependent on temperature by this equation that they're giving you, the tuning is different each time Precious Metal performs. So part A, if the temperature of the concert hall is 25 degrees Celsius, what velocity must the wave on Argenta's guitar string have in order for it to be in tune with Aurelia's reed pipe? So as you can see, I have a little workspace here that I'm going to be using as usual. The empty PDF version of this quiz is on the description, so you guys can go ahead and print it out and then just work it out yourselves. So basically we have two different components to this problem. So we have a guitar and we have an organ pipe. And this is velocity of sound. So we have a guitar, and guitars, you have your strings and they are fixed. So if you have a string and then you make it oscillate, then it basically just dooms like this. So we are working with this scenario. Closed or fixed, whatever you want to call it. So I'm just going to copy my equations. Again, you need to make sure that you know how to derive these equations, that you understand them, but we did an entire introduction video on this, so I'm just gonna go ahead and copy them, and if you guys would like to know where it came from, then just go ahead and click the introduction video. And then we also have an organ pipe. Organ pipes, this is just like a pipe, and they act as a closed-open system. So this would be the first harmonic, for example. So I'm just copying this, so this would be like the pipe. So I'm just gonna copy this over here. Again, make sure that you know how to get this. Okay, so this is a vein problem. Now, another thing that makes this sort of a little bit difficult is that this guitar, the medium is strings. And this organ pipe, the medium is sounds, so just the speed of air, right? So for both of them, not only are we using different equations, but we are also going to have a different velocity. This velocity is the velocity of sound on air. So this velocity actually goes here. So the velocity of sound on air, 331 plus 0.6, and for part A, they are giving us a temperature of 25 degrees Celsius. So for the organ pipe, these waves are going to have a velocity of 346 meters per second. Now, this velocity of the guitar string, I'm just gonna call it G for guitar, but this is a guitar like the string of the guitar. I actually don't know what it is, and this is what I'm trying to find. So let's just go ahead and do that. Honestly, I have my equations for my frequencies, and they are telling me that both of them need to be the same. Now, which frequency? The first one, the second one, third one, which one? It really doesn't matter so long as you're using the same n. Why? Well, because we're working with velocities, and even though this guy has its own medium and this guy has its own medium, velocity itself depends on the medium. So for example, on the guitar, if you're on the first harmonic, the second harmonic, the third harmonic, this velocity is going to be the same because you're still using a string. Same goes for the organ pipe. If you're on the first harmonic, the second one, the third one, well, it doesn't matter because your this velocity of the medium is still going to be the same. It depends on the temperature. It doesn't depend on the harmonic. So what we're going to do is we're just going to, I mean, if it doesn't matter so long as I select the same n, then let's just go ahead and select the fundamental one because that just makes things so much easier. So the first fundamental for the organ, I'm going to do F1 organ, is equal to 2 times 1 minus 1 times velocity. I need to use this velocity because I'm with the organ, so 346 divided by 4 times L. Now L for the organ pipe is 0.75. So F1 for the organ is equal to 346 divided by 4 times 0.75, 115.33 hertz. And we want to take this, and we want this to be equal to the guitar because we want them to be in tune. So even though they are going to have different velocities, what we want is for them to have the same frequency. So we're going to take this number, and what we want is this. F1 guitar must also be 115.33. So given this number that we need, let's just find out what velocity we get from that. So but now I need to use this equation because now I'm going back to the guitar. So F1 guitar 115.33 needs to equal to 1 times V. Notice that I'm using the guitar, I'm on the guitar side, so this would be V of the guitar string divided by 2 times L. And again, I'm using the guitar, so this should be 1. So V of the guitar should be this number multiplied by 2. So 230.66 meters per second. Final answer to part A. Now this problem is, it's kind of straightforward if you know what you're doing at this point, if you know how to get your equations, if you know that velocity depends on the medium, not on the harmonic, if you know how to keep your instruments separated from each other. If you're using the pipe, then use the equations for the pipe. If you're guitar, use the equations for guitar. But if you know well enough, if you're practiced well enough, you'll know to like divide your little page so that everything's separated. And then this is gonna be your answer for part A. So now for part B, the question is, if the temperature, the cat's playing with the toy, if the temperature of the concert hall, oh no wait, so part B is right before precious metal goes on stage, the temperature drops to 20 C. Okay, so now for part B, the temperature is 20 C. If the velocity of the waves on the guitar string remains the same, which makes sense because, the guitar is the string, so the velocity is going to stay the same for the guitar. What is the frequency of the beats that are heard when Aurelia and Argenta both play their instruments at the same time? Okay, so basically, the guitar string is gonna be, we're gonna have the exact same velocity. So for the guitar, we're gonna have 115.33 hertz. But now, this velocity changed, so this number is gonna change. So basically, we just need to recalculate it. So let's see. So velocity of sound now is 331 plus 0.6, but now I'm gonna do 20 here. So that would be 331 plus 0.6 times 20, 343. So it changed. So now I just need to recalculate. So this is organ, and this number is going to be the same. So this is 2 minus 1, so this is 1. I need to put in my new velocity, and this is going to be the same because the length of the organ didn't really change. So my new frequency at this temperature is going to be 114.33 hertz. Now this is something that I haven't explored on videos because I haven't seen the point of making a video just on beats. But if you remember the L, if you went to the L or whatever, then we know that the frequency of the beats is just the absolute value of the subtraction. So the frequency of the beats is absolute value of 115 minus 114, so this is just 1 hertz. And there we go, final answer. So this is the final answer for this problem. Again, even though I consider this to be on the more difficult side because you have two different mediums going on, two different instruments going on, two different ends going on and stuff, so there's like a lot going on. It really becomes very straightforward if you've done a number of these problems. So I definitely recommend a ton of practice on this subject. And once you have enough practice and once you've really mastered this, which I keep coming back to this, but this is it. This is tandem waves. This is it pretty much. Then you are good to go on this topic. So anyways, guys, I hope that you found this content useful. If you did, please make sure to leave a like. It really helps our channel, and I'll see you guys on the next video.